Hello everyone, my name is Amit and I am here to give a presentation on the topic flow through pipes in series. So coming on to the topic, we would be solving a question based on this topic. So the question is, uh, three pipes 400 mm, 200 mm, 300 mm diameters and having length of 400 meter, 200 meter, 300 meter respectively are connected in series to form a compound pipe. The end of this compound pipe are connected with two tanks whose difference in water level is 16 meter as shown in this figure, this 16 meter. So if friction factor for all pipes is same and equal to 0.02, we need to determine the discharge through compound pipe neglecting minor losses. So before solving this question, we will be talking about the concept of flow through pipes in series. So coming on to the concept, so here in this figure three pipes are being connected and their length, diameters, rate of flow and the velocity of fluid flow is given for all three pipes. So since they all are connected in series, so rate of flow Q would remain same in each pipe. Hence QA is equal to QB is equal to QC. Let's say this is equal to Q. Okay, so now this is the section 1, this is the section 2, and we assume that total head available at section 1 is H1 and total head available at section 2 is H2. So now we would be applying energy equation between section 1 and 2. So which says H1 minus H2 is equal to HF, where HF is the loss of head. So this loss of head can be calculated by considering the all the losses which have been incurred in this process during this fluid flow. So the major losses which can be incurred is, first one is this frictional loss in pipe 1. So this is the frictional loss in pipe 2 and this is the frictional loss in pipe 3. We know that the formula for frictional loss through a pipe is FL V square by 2dg. So these were the major losses which were incurred during the flow. So now coming on to the minor losses. Minor losses could be due to the change in cross section when the fluid is flowing from pipe A to pipe B, and also the change in contraction when the fluid is flowing from pipe B to C. So when fluid is flowing from pipe A to B, there is an increase in cross section. So that loss would be counted by this term, VA minus VB ka whole square divided by 2G. Okay, so the loss incurred due to contraction can be counted by this term, Vc square by 2G 1 upon Cc minus 1, where Cc is the coefficient of contraction. So this is the coefficient of contraction. So in this way, by comparing equation 1 and equation 2, we can account for the loss of head. So applying the same concept in our question, we are given with the diameters of all the pipe and their length, and we are also given with the difference in height of the two tanks. So let us assume, let Q be the volumetric rate of discharge through the pipe. Then velocity of flow in pipe 1 would be Q upon the area. So Q is given to us and the area is pi d square by 4. We know the diameter for the pipe is 0.4 meters. So the velocity for the flow in pipe 1 comes out to be 7.96 Q. So applying the same rule, velocity of flow in pipe 2 would be Q upon pi d square by 4, where d is the diameter, that is 0.2 meter, and the velocity came out to be 31.83 Q. So now coming on to the velocity of flow in pipe 3. So that would be Q upon pi d square by 4, where diameter is 0.3 meter. So the result came out to be 14.15 Q. So now we have calculated the velocities. Now we would be calculating HF. So for calculating HF, we have got two methods. So one is application of energy at section A and B. So these are the sections A and B. This is the section A, this is the section B. So we would be applying energy equations at section A and B. So by applying those, we get pressure head PATM plus rho g plus velocity head, since velocity at section A and B, section A is 0, plus the difference in height of section A and B. So this is the pressure head at B. So this is the pressure head at B, and this is the velocity head at B, which is 0. This is the gravitational head. Since we have considered the datum at B, so this is 0. Plus the HF is the frictional losses which have been taken into account. So by solving this equation, we get HF is equal to 16 meter. So loss in head is 16 meter by method 1. Now coming to method 2. So since we are given that we have to calculate the discharge neglecting by minor losses. So we are neglecting the minor losses and we are considering only the major losses. So major losses are due to frictional loss in pipe 1, frictional loss in pipe 2, and frictional loss in pipe 3. So we are given with the frictional coefficient for each of the pipe, that is 0.02, and we are also given with the length of each pipe, that is 400 meter, 200 meter and 300 meter, and the diameters for each pipe are 0.4 meter, 0.2 meter and 0.3 meter. So putting on all these values, we get a HF is equal to 1301.46 Q square. So now comparing equation 1, HF is 16 meter, and comparing from equation 2, HF is 1301.46 Q square. So equating 1 and 2, we get Q is equal to 0.11 meter cube per second. So discharge through pipe neglecting minor losses is 0.111 meter cube per second. Thank you.